So, welcome everyone to our session with respect to post-processing update on 2024.1 release. I'm going to start the introduction with HyperMesh Post. Then I will be handing over to Sandesh to drive you through the enhancement done in HyperView and in HyperGraph. A lot of things have been done for this release. I'm going to show you, as I was mentioning, the part belonging to the HyperMesh Post. On the HyperMesh Post side for 2024.1, I'm going to go through the main enhancement. First and foremost, you have been seeing in the previous releases, we are moving on enhancing and boosting the offering with respect to what are the derived load case types. And for this release, we have been adding the type steps. Is surely nothing new for those that are obviously familiar with the HyperView. The step type basically build a kind of transient case by joining different simulation type step. As you know, in the previous releases for HyperMesh Post, we have been adding also the root squared sum to the envelope and LSP. Now we're adding the steps. We have been adding the animation. So you see where the journey is going. We are working actively as well to support all the type of transient results and specifically what we call the explicit solver supports. So we are working hard to get as well radios, Dyna, Palmcrash supported and officially exposed in the upcoming releases, and type step, which can be used for also for frequency response and so on and so forth, is now available in the 2024 release. We have been making several enhancements on the complex filter, and we have been introducing two new complex filter. One is the phase whip, and the other one, which I'm going to show you live, is the closed form, specifically for von Mises stress, and we're going to introduce it in the next release also for the von Mises strain. I will spend some word about it on my upcoming live demo. We have also made some cleanup on the complex filter. I will spend some words. And we as well introduced new invariant, new in the form of what was available in the previous releases for HyperMesh Post. This is nothing new when it comes to HyperView. So the load param xi and the load param theta. These are now available for stresses, only for stresses, not for strain. And we also aligned the type of let's say invariants that are exposed with respect to the tensor type, being this a stress tensor or a strain tensor. So the way the roadmap is definitely to harmonize more and more the offering and the workflows between the two platforms. Last but not the least, we also created an option, or given the option to create a default deformations on loading results. This could be very useful when you want to run animations and you don't have to click every time to create a deformation, which is obviously required to see the animations of your model. There are a few other updates that I'm not listing here. Obviously, they will be part of the release notes. I just want to mention that we have been enabled also officially to import the HW-ASCII results from the results workflow. We have been also making some extra rework to have the beam stress workflow to support not just the OP2, but also the native OptiStruct H3D results. Made some cleanup on the wording, import message and warnings, and some cleanup on the context menu from the result entity. So a few things. Obviously, fixing bugs, improving performances, and so on. But if you wish, what you're reading now in this page is, let's say, the focus of the major enhancement. To give you the feelings, I'm using the latest mail line here of the struct profile. I've been loading a model, and I was mentioning, so we have been adding these capability to create a deformation plot on loading results. If I'm switching this on and then I'm going to again, say file import results. Now you see, as I was mentioning, the HV ASCII, for example, I'm going to open the OP2 related here. And the first thing that you can obviously see is that there is going to be a plot control of type deformation, which is automatically created. Obviously, this is requested for running an animation. As you know, animation was the big entry of the last release. And we wanted to streamline this workflow. Now, these options will be off for this release by default. We're planning to activate it on because we still have to, let's say, fix a couple of glitches and make sure that the workflow is streamlined for everyone. Obviously, the deformation as any plot control can be activated or deactivated on demand. Same for the drive load case. As I was mentioning, now we have, together with the superpositions, the envelope, and the new entry RSS from the previous release, we are beyond the type steps. The type steps doesn't have any specific options here. You just need to take the simulation step of your interested, hit create, and then get to a newly created drive load case, which is nothing than a filter or a summations of the different simulation step that you can, let's say, extract from a single subcase or from multiple subcases. Obviously, this has been heavily used, namely in simulations of transient in time, but as well can be useful for a frequency response where you want either to chain or join, let's say, different frequencies, or ideally extract a subset of frequency to run your type of analysis, right? So this is more or less in a nutshell the scope of this work. I was mentioning as well about the newly introduced complex filter and rework. It seems as a minor one, but we have been spending quite a lot of time on cleaning this up and trying to avoid future, let's say, inconsistencies. So we will be working as well on the HyperView side, but namely to make sure that we have a solid, robust offering. So you see here when I create a standard contour plot control. The default is set to displacement magnitude. Obviously, we have also the component. When you go into a non-raw data, so nothing that from a vector is either the X or Y or Z component, or any of the 6 stress raw tensor component, we are just exposing, if you wish, the expression in time of the complete harmonic function. Why this? Because in reality, when you go in the complex domain, the only pure harmonic response that can be really expressed as an harmonic function, either with real and imagery or with magnitude and phase, so either scalar or polar plot, are the raw component. All the other quantity, being this a magnitude for a displacement for a vector force, or, for example, the stress tensor von Mises, the Max principle, and so on and so forth, they are not anymore harmonic functions to that extent because they cannot be expressed as such. So the only way you can really extract the information and what is the quantity that you are extracting is the maximum across the omega t, so the angular velocity. And therefore, for the raw component, you can express the real, the imaginary, the magnitude, and the phase, while for, let's say, I go to stress and then P1, for example, I have an expression of magnitude by cosinus plus or minus phase. That means that I'm going to, for each component of the stress tensor at a specific omega t angle, which is the one defined by basically, namely the animation toolbar, I'm going to set the idea, actually the real value, so the expressions not in a complex way, but in the real way of the tensor, and then extract the relevant value. That means that the P1 will change depending on the several angles or omega t that I am extracting. this goes to the next level that I'm going to express. What are, if you wish, the KPI that we need to extract? The KPI are in general for an invariant, let's say the max principal, which is ideally the expressions of a brittle failure, is give me the maximum or the minimum, right, of this quantity. In a frequency response, or in a, let's say, in this let's say harmonic expression, its maximum is going to be the maximum across, let's say, a range of angular omega t going from 0 to 360 degrees. Being this not an analytical close formula, we need to sweep from each frequency, actually from each omega t at each frequency, of a specific delta. And this is what the phase sweep does, right? And we have introduced this one phase sweep also with a sweep mode. Basically, it will evaluate every invariant, every, let's say, derived value from a vector or a tensor, in this case a tensor, and then evaluate it for each omega t delta a specific phase sweep, which is actually defined in the preferences. And you see here sweep angle, we have a default 45 degree. And then it will take either the maximum or the minimum or the extreme values. So there is an iterative process for each element, each node that we are looking at. And this is extracted, but automatically given as a complex filter. For those who have been going through the exercise in HyperView through derived results expression builder, this is very much likely what some of you may have been doing via the scalar extract. Now, instead of bringing, let's say, extra clicking and extra understanding, the idea is for the base mathematical operations, our aim is to bring them up front and ready to be used as a default options whether possible. And the message that I want to give to you as an overall audience is that this is not just for the complex filter. This is something that we are really working hard to make sure that the default and the most used will never require any extra click, or more than, if you wish, one click or two, and not require anyone to learn how to use an extra dialogue, an extra expression builder to do something which is a given, let's say, standard in not just in the literature, but in the common praxis of engineering world, right? So remember, we have the complex filter harmonizations and also the new complex filter phase sweep for all the type of derived value. And for the von Mises stress, in this case, we've also added the so-called closed form. Now, this is available only for von Mises stress, is done with the assumption of having basically no phase shift between the several components. So we are using the Cartesian expression, and then we are evaluating this as a kind of a closed analytical formula. This can be only done for elemental bound values and not for the nodal one. So there is no possibility to do this other transformation and averaging. And for the next release, we will be also exposing it not just for the von Mises stress, but also for the von Mises strain. Obvious questions, why just for stresses and not for strain? It was just a question of time, to be frank with you. So we didn't have the bandwidth to implement and test it. This is coming in the new release. Okay. And obviously, you can even imagine the other direction. This is specifically, I would say, for most of the MVH or let's say frequency response related questions. In general, let's see, you have the von Mises complex closed form. So it's just one value across all the let's say omega t, and in fact you can see I can animate or change the omega t, but nothing changes because this is constant. We are going to use it in the close future also as a metric for an envelope. So the KPI for a frequency response is not just to extract what is the maximum, let's say, brittle or yield failure quantity, being this P1 or von Mises, for example, but doing this across the complete frequency spectrum. And therefore, being this a scalar metric, this is a scalar metric that we are going to use and expose in the close future also for the envelope definition. Okay, so just to give you a let's say a logical sequential step of what we are doing and what is the directions that we are heading to. Last point that I wanted to mention here is, and let me go to a static case just for completeness, is the rework of the data component or invariance. You see here that for a stress quantity, in this case, we have been adding, as mentioned, the load param xi and theta available as well since many releases in HyperView. We have been adding it also in HyperMesh Post. And what else? For the strain, though, we have been reduced the number of quantities, making sure that obviously an invariant can be seen just as nothing but a mathematical formulation. We have been using this kind of, let's say, bluntly or brutally. Allow me to say that we are now have, I wouldn't say the luxury, but more bandwidth to harmonize and clean a little bit some of the inconsistencies that due to the pressure that we had to release and we wanted to release and provide more functionality to the users. Anyway, some inconsistencies was there. It was raised with good argumentations and with rights from you guys from the fields. We have been cleaning this up. Now you can see that, for example, some of the for example, the previously named load param are not exposed for strain. This goes also for the Tresca invariant and so on. So a little bit of cleanup has also been done under the cover to make sure that we have a cleaner solution to be exposed. I'm sure that this covers what I wanted to express. And now, without any other indulgence, I would like to thank you for your attention on my part, and then hand it over to Sandesh for the next juicy ups. Thanks, everyone.
Hello, everyone. This is Sandesh. Thanks, Michele, for passing the baton over. We'll first start with the updates in HyperView, and then we'll follow up with hypergraph updates. For this release 24.1, we have integrated all the report updates also within HyperView product. So, this is a combined update for everything that is coming from HyperView. We have first decided to focus in this release on the 3D model generation topic. It has been a widely demanded feature as well. The main goal being that we want to provide some means for our users to share and collaborate result insights. Those results insights could be in the form of mini reports. It could be just a 3D model that is shared across the teams. For the longest time, we have always had H3D as a solution that was doing this job. But then we realized that we also need to reach the newer ways of exploring results where the users are going towards. So we realized that, we need something that can work without HyperMesh installation, and it may be required to work on other hardware platforms than just our regular work machines. Then, in addition to that, we also realized that even if we are providing this model, we need some way to quickly get more result insights. So if I have a certain model on the screen, if I click on a point, I should be able to probe what's going on there with the values of the results, or can I just isolate that part and see it more closely? And then beyond that, there is also about integrating into other systems that are beyond our HyperWorks ecosystem, such as maybe PLM tools that our customers are using, or maybe they want to just view these results in VR and AR application, which also goes to the different hardware platforms where the users are heading towards. Or sometimes they just want to take uh, a model that has results or deformations into 3D printing. So with all these use cases, we had to expand the goal beyond H3D, and to accomplish that, we have come up with a new feature. Now, this 3D model export, it also obviously includes results since we are exporting out of Hyperview. We have decided to split this problem into two ways. First is light view, where the goal is basically the data portability, minimum viewing dependencies, where you would definitely not need an Altair tool to view it. You can view it, in fact, in any tool in the market that is, usable with GLB files. I'll quickly explain what GLB is. GLB format is a versatile and a widely used 3D file format. It has gained a lot of traction and significance in recent years. You know, in the in the very fewest in the fewest of words, I can call it the 3D version of JPEG, or JPG, the popular image format. It is a binary file format that is initially a container for 3D assets and resources. So you could think of materials, textures, animations, all of that can be contained in GLB. Of course, it's a binary version of a popular format called GL, transmission format, or also known as GLTF. Enough of that though. So this is GLB. We are going to see the glimpses of it, how cool that looks on the screen and also while exploring it. Then the other side is H3D. This solution has existed since so many years. It's just that now we have decided to expand it in another form. H3D will be, it's going towards a rich view. The goal there is to provide a feature-rich viewing experience where you have access to model tree, animation, notes, and section cuts, which are typical for our post-processing users. And even result data can be queried. You can click on a certain point and you can know what's going on that point. That's really important for our users who can have questions, right? Whereas GLP goes towards our platform independence, where you don't have to really see anything from HyperWorks ecosystem. So the GLP really goes towards viewing the model directly. You can simply open it in Microsoft Windows-based viewer. There is a popular 3D viewer. We are going to use that during our demo today. It can also, and that viewer is actually also known to be usable for VR and AR applications. Beyond that, it's also known thing that GLB can be opened in many 3D printing applications as well, where you can simply feed this file and it will create the model for you. So GLB goes there. The way to get there is the file export menu that we used to have in Hyperview. Now it has been upgraded to say 3D model instead of just model. And that will bring up this new dialog that will have all these options integrated in one place. This GLB can also be integrated in PowerPoint documents or in general MS Office based documents. So far in our testing, we only found MS Office to be fit for showing GLB. There could be many other tools. It's just that we haven't tested that with GLB. Then switching over to the rich view side, Hyperview player with HCD has always existed. It will continue to exist and it will continue to serve. So this dialog obviously has those options already there. You can also embed an H3D into PowerPoint or documents, and it can be viewed in MS Office based viewer and MS Office, which integrates well with Hyperview player, and that's how you view it. And now with this release, we have also expanded the goal to also create a new HTML. So you might recall that H3D in HTML wasn't a different theme. We used to actually embed H3D files in HTML. But with some technology dependencies and the enhancements in the browser protocols, we had to part away from that old solution and we had to come up with something new. Now with this new HTML, it is actually a self-contained file where the viewer as well as the 3D model data is all contained within the single file. So that means I would not need any Hyperview player, or I would not need any player for that matter. I just need my regular browser. And the browsers are Chrome, Edge, Firefox, Safari. So you can be sure that whether you are on Windows, Linux, or even iOS, or any of those platforms, you are able to view these files no matter where you are. So that's really the gist of it. Uh, I'm going to now get out of the presentation mode and simply look at this slide in the viewer mode. I was looking at this like a 2D image, but now this being a GLB file, I can actually interact with it. And because the results legend is right here, I can tell that, okay, for this eigen mode, the maximum value is coming out of this point, and I can quickly peek under the hood and see what's going on. This is really it just changes the game altogether. We don't have to rely on 2D images anymore in our presentations. This slide can be exported from HyperWorks, and then you can take this slide anywhere you like in any other presentations. So that's the best part about it. Then going over a solution that has always existed, the H3D. This is just there, just wanted to make sure that this is also a known thing, that H3D file can always be embedded inside PowerPoints or document files. If you double click on this, when H3D is embedded, it simply launches Hyperview Player. This is not new. I'll repeat again. This is a solution that has existed. So if you install HyperWorks, in general, Hyperview Player comes for free. If you don't have HyperWorks, you can download Hyperview Player for free from our Altair marketplace, and it will work with your Microsoft Office installation, just like how it is working for me right now. Here you can animate and do a lot of things, and also create section cuts or apply maybe measure a few things here and there. So, this tool is already there, and it has been doing a great job for us over the years. Then we go into the next mode, which was about viewing the 3D model in HTML. And actually, at this point, let's jump into a demo. So on my screen, I have a truck model. I purposely took this file because it's fast to load, and it's light enough that we will focus more on the demo rather than the file size. So we in this model, I have some 50 or 30 frames of animation. I have created some nodes, so you might see there is a node of where the maximum value is. There is a note that I have added as a message to somebody on my team that, hey, this part is crushing more than normal. And then I also wanted to tell my colleague that, hey, we need to replace this part from this simulation. Maybe it's an older version of where it is right now. So with this messaging, I have this to share with my colleagues. So there are multiple ways I can do this. Well, first I'll go to File, Menu, Export. And this is the option I was talking about, that this option has been upgraded now. When I click on this, I get this new dialog called Export 3D Model. It has multiple options. So if I stick to my defaults, it will always start with 3D model H3D. And this is equivalent of how H3D export used to work all these years. So no, that changes for nobody. You can simply open this dialog and get your H3D export right from here. However, if you wanted to try GLB now, all I'm going to do is click this. There are a few things that we have intentionally decided not to support in this release. So it will already disable those options, so you know what's going to work and you have those options to check or uncheck. For this demo, I'm going to just select everything that is possible. And there is a new checkbox that we have introduced, Open After Export. What it does is when the file is done with creation, it will simply open it for you on the screen. I'm going to hit export. I'm going to say GTA demo. So you remember that we have stress one misses applied on the screen. We have some elemental contour on the screen. When I hit save, it exports so quickly that it will simply open this file. Now the viewer I'm looking at is actually the Microsoft 3D viewer. It comes for free with Windows 10, Windows 11. Maybe in Windows 11, you'll have to download it from the App Store, but it comes for free for everyone. So, well, here is the animation of this truck deformation. The good thing, this is what HyperView already does, right? But because this is a VR based, or this is a viewer meant for VR, you can actually get inside the model and see what's going on here. And maybe in this case, what I'll do is just stand here, imagine the driver was right here, and see what happens to them. So there are plenty of possibilities how I want to explore this model. This is just one example. There are more things that I had ready in this session. If I go to page 2, there is an airplane model. So think about the same way. Well, I can go here and see this plane model where I can simply walk inside and see what's going on here. So there is some deformation that happened here when I was applying some loads in X direction with 1G loads. So I can tell, this is where my critical regions are. You also notice that because this is a third-party viewer, they don't understand the language of nodes and measurements that we typically use in Hyperview. And that's also the reason why this data does not really get exported over there. I mean, it might exist in GLB file, but you will not be able to see it in the viewer. It really depends on the viewer. So this is the GLB side of things. Few things that we have decided to support intentionally. If you just change the number of levels to maybe less. Well, okay, so this tells me what is my critical region, what could be the warning region, and what is the safest region. Just an example may not be meaningful with this example itself. So now if I just export this, and this time I'm going to say GTA demo 123. There it goes. So now I can think about this, that I can automate a script that runs always on the server and runs after every simulation, which opens Hyperview, applies some legend settings, and creates this model for me. So I can tell right away what is good and what is not so good about this simulation. And this is a very well documented feature. Thanks a lot to, again, Eleni here in our team, who did a great job in helping us out on this. But yeah, so this is right here in 24.1. Now, let's move on to our other parts of this demo. So I'll go back to my default legend. This is how it was looking. We have a couple of nodes created for inquiring the values. There are a few nodes that I have made as a user. And then while viewing this model, I was also looking at, these are my important viewpoints. So clicking here, this is where most of the crush is. This is how overall the model looks like. So there are a couple of views that I have stored, and then there is dynamic min-max that I have always activated so that I can look at it while the animation is going on. So now I can also share this with my colleagues in an HTML format. The good thing about HTML format is, well, okay, if I click this, it's going to, again, ask me similar questions like an H3D file. We want entity attributes, which means mainly the colors, transparency. The tooltip is going to help you here, or the view attributes or animations and results. I'm going to hit export with everything selected. And I'm going to say demo TTA. So now the model export is in progress. You're going to get this message. And eventually in a few seconds, you're going to see this model opening up on the screen because we have selected that option. So we start here. Now you look at this HTML. If I look at this HTML in the file itself, we were creating some HTML files. You look at this file. There is no resource folder for this HTML. You can look at the file size. You can tell by looking at the file size that this has everything in it. So this is HTML coming here. It looks different than Hyperview because this is the, let's say, how all our applications are going to look like eventually. This uses a new graphic engine. We actually collaborated with our Altair 1 team, the team that is specialized for cloud solutions, and they were providing this offline viewer. So this viewer has newer graphics. When we begin, you actually see the animation already working for you. And this is where we started from Hyperview, right? But now beyond GLB, you also get a tree here, the par trees, which will allow me to select a certain component and highlight that in the tree. Or I can just decide to uncheck a few components and see the model for myself. Beyond this, I also have the nodes that we created in Hyperview. I can check or uncheck those if I did not want to see them. At the same time, I can go to views and say, hey, just apply the view 2 for me, where all my critical regions were occurring all this time. Now I'll go back to the temp view. We just looked at the part tree, and we're going to hide that now. There are other options like switching to perspective view or fitting or rotating to the closest view cube location. Now, good thing about this is it also has a section cut. I'm going to apply that in YZ or ZX direction to make it look nicer. And now I get somewhat similar view what we were trying out in GLB. Then another nice thing to show about this is this explored view. Now I can even play the animation like this. This is one of the wow factors of this HTML. Really great job done by the development team and tested very well by our QA. But this feature really makes a lot of difference for a lot of our users. So this is definitely worth showing and trying out. Now, once we explore everything with the model, we jump into the results, right? So we earlier decided to turn off the nodes. I'm going to go back to the part tree and say, hey, I want all the nodes back. So they come back here. But while I was creating these nodes, I'm going to now turn off explored view. We were looking at these nodes, right? But now I have a question. Oh, what happened at this particular point? What is it trying to say? All I have to do is simply click this call out button. And when I do this, either I can put the element ID here, or element ID because this is an elemental contour, or I can simply click on the screen and I can tell what the value is. You can also realize that whenever I click on a certain value, the color of this box actually matches with where I clicked. So if I click here, this box will likely go with the color of that cell. Then you also see that the max value, because it was in red, it shows up in red. Minimum value is in blue, whereas all the nodes created from HyperView are in blue. So this is how the callout feature works. Looks like you can always get a list of those callouts, which will list the values that you got from these nodes. This only happens for the callouts that you created here. And then the min max that you were always looking at, you can always turn it off or turn it on again. And it will give you the latest and greatest value while you are playing your animation, just like HyperView measure. Because we also exported the animation, we are getting the animation, but because of the animation, you also get the displacement plot here. So you can now change to a certain time step and you can look at the results. More or less, you can, if you have used HyperView players over the years, it will remind you a lot of HyperView player. We have basically benchmarked with the same tool and tried to match the functionalities as much as possible. But this is right here for you to try and use this in your regular day-to-day use cases now. All right, so we come back to our presentation. So far we saw that there is GLB that we can create. You can also embed this GLB right here. So if you go back to the product and just go back to export 3D model, if you select PPT as an option, we have added this new functionality to just embed any of these files with the options that they support. When I export this, it will basically create a one slide presentation for you that will have this legend along with the GLB file, or it will create a slide like this, which has the H3D already embedded. So this can be more portable for you. So that being said, let's come back to our discussion on other features. Now, beyond this, let's also go towards other HyperView upgrades that we have done in this release. As communicated previously, we have been investing a lot in our HyperView multi-core profile. The goal is to actually replace HyperView General altogether with this HyperView multi-core because it is the performance efficient twin of the two. As a part of this effort, in this release, we have enabled extract and linearize tool. More and more tools will be rolled out just in a very similar fashion in the upcoming releases. Then beyond this, there are several small but very useful enhancements. The section cut tool, right, within HyperView, we have made an enhancements to add a micro dialog that will help you directly put a value where you want to place your cut plane. And you can also increment easily, just beyond just using the manipulator, you can also put the values here and increment or decrease the values by a certain step size. Then the measure tool in HyperView, we used to use, if you disable the auto create, you can create a measure group. But it was, now with this release, you can also edit the measure group by adding, either changing the list of entities selected or adding a few more. So when you go to the measure group, for example, in this case, we have created this global measurement for distance between two entities. So you can click this new button where it will edit the group. And it also has a tooltip that will guide you through this workflow. So now, because we are editing, you can now click your values and you see how it is getting added to the list of things. All of this, if you just expand this entity in the browser, it's going to list all those measure pairs. Then we, while upgrading the measure tool with these newer enhancements, we also added certain preferences options in the preference file. You can now set numeric precision, format, the units of the angular measurements in the preference statements. This is also very well documented. So if you go for the preference files documentation, you're also going to find the list of all these along with other statements that we make in the preference files. Then you can also control the style of nodes that are connecting to the entities, whether you want the continuous line or triple lines or dotted lines. So there are multiple options now. Actually, before we jump to other things, there are other enhancements that we haven't really mentioned on the slide, but the entity selector, for example. So if I go back to HyperView, I can quickly show you. There is enhancement in entity selector. There are few new template statements added, or template expression added to query the base load case or simulation step in case of derived load cases introduced. And then there are some performance upgrades in the HyperView hotspot tool. So, one thing that you can notice also is if you have multiple windows on same page, right now my selector here says elements, right? And I get to select elements. But if I switch to other windows, now it will remember your settings on these selectors. So now here also I'll continue with the element selection, which makes it very simple to now jump between windows and continue with our exercises. So that being said, this is all that we had to share from HyperView side. Now let's jump to HyperGraph side of things. In this release, just like previous releases, we have focused in HyperGraph mainly on upgrading our look and feel. We have continued with our exercises to replace panel and enhance the functionalities during that replacement. So we have started with this math panel or macro panel that was pretty popular for adding new macros, creating nodes, or creating new curves with the formula. The panel has been replaced with a dialog. Now this dialog has some extra functionalities. We can quickly go over it in a demo here. But you will also see that this is the consistent layout across the board. So even if you apply stack math and you try to edit the stack math function, you'll get the very same look and feel as the math dialog now. Along with math dialog, you'll also see the values panel being replaced by a new dialog. And it has also been enhanced pretty super efficiently, I would say. If you click on all the curves on the screen, now you're going to get a big table that has the values of all the curves. And then you can obviously set the scale from linear to log and do some changes, or even probe the points. So while probing the points, if I go to the maximum of one curve, you're also going to see what happens to the other curves at the same point, because you have also enabled those curves in this table. You know what, let's actually just jump into a demo. So in this session, I have 3 pages of HyperGraph windows, plenty of curves as usual for any user, right? So plenty of curves here. First thing I can think about is, okay, I've selected all of this, and this panel is already telling me what is the min, max, or min and RMS. So it does a great job. But I can quickly go to the values panel and it's going to show me all these values, right? So because it's a dialog, I can take it to my other windows, and then I can continue with some actions or some interactions with my window here. If I click on any point, you see that the point is getting highlighted here in the window, but it also tells me the values for all the curves that I have selected on the screen. Then I can change the linear scales, or I can go to the maximum of a certain curve because I had selected this curve for now, P1, W1, C1. So that's why it's going to the maximum of that. But if I had selected another curve, it will go to the maximum of the other curves, and then it will show me what the other curves are doing at the same point in X. So that's the nice thing about the new values dialog. So this is the resultant angular acceleration plot. Let's say I want to create an integral of this to get the velocity. So this is when I typically use either stack math or values or macro panel. So if I click this is the new macro dialog or math dialog, we call it. This has listed all the functionalities already here. I can quickly just type SAE, and it will help me put the SAE filter on the screen, for example. If I wanted integral, just type integral and it's going to come up here. I can also search it with just saying int, and it's going to give me everything that has this keyword right here. So search functionality also does the job for you. So maybe for this example, let's try to apply integral. So all I have to do is select the curve. Here in this case, I wanted to select the angular acceleration. Now here from this dialog, I have an option to simply apply this as a stack math because I changed my mind. So if I do this and hit apply, it's going to apply it as a stack math. Whereas if I just continue with my previous option of creating a new curve altogether rather than touching the original curve, it's going to do that. When I hit apply or OK, it's going to accomplish the job for me. So it created this new curve and decided to hide the old curve. So this is the new curve I got on the screen. Now, if I go to the old curve and simply decide to add a stack math, let's say I click add stack math operation, you see that even for the stack math, we allow a certain list of features, right? Or a certain list of functions, but this dialog looks very similar to how the math dialog was looking like. So this is where we are working on the consistency and also the modularization of our code to make it more consistent across the board for everyone. So here in this case, it has already selected which curve we were trying to integrate. So I'm applying this as the stack math this time. When I hit OK, it will apply this as the stack math, and I'll enable this curve. Now, because I enabled or applied the stack math on my original curve, the dependent curve now has double integral. So it is now showing the displacement, which is also an expected thing. And that's the great thing about Hypergraph, that it does the math so efficiently for you and it keeps you updated with the math. Anyway, so this is what the math dialog is doing, or the values dialog is doing. One thing I also forgot to mention, if I had selected the curves here. So earlier we looked at the values dialog from here, right? So I clicked the curves here and clicked the values dialog. But for some users, we realize that they find it very comforting to use the browsers more often than not. So if I selected only two curves and simply say values, then they will get only those two curves listed here instead of everything else. And then you'll follow the rest of the exercise. So that's the good thing about values dialog. Another thing that we are going to look at in our slides anyway, quickly I'll go there, is the define curves dialog. This was the one that we released during 24.0, the last release. At that time, the functions list was all in a big giant list. It wasn't sorted in any fashion. Maybe you could sort it only by ascending or descending order by name. But now you will see the categories of function, which makes it extremely simple to find it in a list of in a giant list of functions. That being said, I can still go for what I want to do just by searching this in this list. That doesn't take away the search from you, but it also makes it very easy for you to find the functionalities quickly. And then once you click anything, the rest of the entity editor will follow, and you can go ahead and add the functionality or add the expression here or evaluate it before even using it in a curve. So all of that will continue to work just the way it used to. So coming back to the presentation, we decided to replace the two panels with dialogues. Defined curves dialog has been upgraded with the categories of functions. Now, in this release, you'll also see our preferences in the build plots to set certain options for complex plots. It only means that you can set line color for and everything you read from with a certain criteria will be applied a certain color. Makes it very simple to identify files quickly from that are coming from a certain result file. Then even table view has been upgraded to import the CSV files with special delimiters. So far, we used to work with only comma separated, but now we have also added the support for tabs, semicolon, spaces, and some other delimiters. So, that's the wildcard part is the exciting part in this. You could be creating CSV in any fashion, and it's going to work for you now in table view. Then there are certain seam reader enhancements. We decided to support newer releases and newer element types or newer result types in seam readers. Same goes for OptiStruct as well. And then certain debug template statements have been added with UTF character support. And this actually was driven mainly by HyperStudy users. They wanted to debug certain templates functions with functions such as isFinite or nan or catch. Those are especially useful when you're dealing with infinite amount of data or when the data size is not certain. That's when these statements come really handy. So our development team has done a great job of adding those and making it very simple for our users to spend more time with templates functions and accomplish their goal with HyperStudy. So that's it from Hypergraph as well. And with that, we come to the end.